Hello to you watching this video, and in this pre-recorded lecture we would be discussing about centroids and centers of gravity. And as you might have noticed already, both of these terms right here have a common root word, which is center. So once again, center of gravity and centroid. So let's talk about centroids first. So when we are to when we are to talk about centroids, we are actually referring to the geometric center of a certain body. So for example, that this is to be your certain body, its geometric center, which is in this part right here, is to be your centroid. So it would be as simple as that. So once again, we are only to deal with geometric center. So we don't care about the forces here, the weights, and whatnot. We are only concerned with the geometry. So to put it in a more technical term and to put it into a more specific term, our centroid is actually the average of all points in a certain figure. So for example, that once again, this is to be your certain figure. If you are to plot it in a Cartesian plane, and if you would be getting all of its coordinates along that shape right there, if you would be getting the average of all the points, you would arrive at a certain coordinate, and that certain coordinate would be what you would be calling centroid. So that is for centroids. As for the center of gravity, so basically your center of gravity is actually the point where the resultant of the forces acting upon a certain body falls. So basically it is the location of the resultant of all the forces that acting upon a certain body. So let's take this spoon right here for an example. So of course, this part of the spoon right here has a certain weight. So let's say that that is to be weight W1. So let's say W1. And as for this part of the spoon right here, so let's pretend that its force act upon this location right here. So let's say that that is to be W2. So its location, its resultant, of course, would be equal to W1 plus W2. And let's call it as W. And using the principles of moment, if you would be getting the resultant of both of these, it would fall upon a certain location with the magnitude of W1 plus W2. And let's call it W. So let's say that this is to be W1 plus W2. And let's say that that is to be the resultant W. So once again, W is equal to W1 plus W2. And the location of this resultant right here is actually the location of your center of gravity G. So it would be this one right here. So if this point right here is to be your center of gravity, if you would be holding this part of your spoon right here, your spoon would be balanced. So why is that the case? Because if that is to be your centroid, so let's say that this is to be x, so distance x, and this is to be distance y. If you would be getting their moment about this point right here, W1 times y is equal to W2 times x. So that is for the center of gravity. So once again, your center of gravity basically is the location of the resultant of the forces there. But take note, guys, that if you have a certain material which is homogeneous, and by homogeneous, what we mean there is that throughout your certain body, so for example that this is to be your certain body, if it has the same density throughout, and if it has the same thickness throughout, then our center of gravity is also located in the same location as with your centroid. So as you can see in this example right here on the top, so let's assume that this certain material right here is of an homogeneous nature. So once again, it has the same density throughout, and let's say that, for example, that it also has the same thickness throughout. Its center of gravity would be located in the centroid as well. And as you can see here, this is a rectangular one, and its center of gravity is located exactly at its geometric center. So it would be like that. And moreover on centers of gravity, so let's have an example or a three-dimensional example of the center of gravity. So once again, like what I have said earlier, that your center of gravity is actually the location of the resultant of the forces acting upon that body. So for example, that this is to be your body and this is to be the forces acting upon it. So W1 and W2. And if you would be getting the resultant, so W1 plus W2. And in this case, the resultant is equal to magnitude W. So this is to be its magnitude. So for you to get the location of your center of gravity, just get the location of that magnitude W right there. But how can we do that? If this is to be in a three-dimensional plane, so if that is to be in a three-dimensional plane, you must get it, you must solve for its location upon every axis that you can solve for. So in this case, we would be solving for bar x and bar y. And bar x and bar y is the distance from your origin. So it would be from here up to the point of your center of gravity. So once again, for your bar y, it would be this location right here. And as for your bar x, it would be for this location right here. And for us to solve for those, what we would be doing is to break them down into components. And one component is to be the x component, or that we would be solving for it using the x-axis first. So let's pretend that this is to be one axis right here. So this is to be x. And if you would be looking at here in the bottom part, this is actually the x-axis projection of the body. So that is to be x, and this is to be y. So this is to be y. And if you can see here, this is to be your y-axis. And for you to solve for the location here, we would be taking the moment about the origin here and just solve for this bar x right here. So how can we do that? So once again, your weight W is equal to W1 plus W2. And the idea behind this is that the moment, so I will just erase this first, the moment that is caused by this resultant right here is equal to the sum of the moments of these forces right here. So let's just represent it via equation. So in this parts right here, so solving for x, solving for bar x, so we would be taking the moment about this point right here. The moment about your resultant, which is W, times bar x is equal to the moments of both of these forces. So that is to be W1 times lever arm. So this is to be W1 times lever arm, which is x1, plus W2 times x2, which is the moment induced by the second force. Since our W is equal to W1 plus W2, so our W here is equal to W1 plus W2. So times bar x is equal to W1 x1 plus W2 x2. And what we are actually solving for here is the value of x bar, or the location of the centroid about the x-axis. So for us to get the value of bar x, so we would be dividing both sides by W1 plus W2. So ultimately, if you want to solve for the value of your bar x, so your bar x would now be equal to W1 x1 plus W2 x2 over W1 plus W2. So that is for the location of bar x about the x-axis. So solving for bar y, so once again, we would be getting the location of the resultant of both W1 and W2 in the y-axis. So and that location would be bar y from the origin. So solving for bar y, once again we would be getting the moment about the origin, and the moment induced by the resultant is equal to the sum of the moments of the forces W1 and W2. So it would be these figures right here. So your resultant times your centroid, so your resultant, which is W, times the location of the centroid bar Y, is equal to W2 times Y2, so W2 times Y2 plus W1 times Y1, so plus W1 times Y1. And once again, your variable W here is equal to W1 plus W2. So W1 plus W2 times bar Y, that is equal to W2 Y2 plus W1 Y1. So for us to get the value of bar Y, we would be dividing both sides of the equation by W1 plus W2. So W1 plus W2. So ultimately, you would be having an equation of bar Y is equal to W2 Y2 plus W1 W1 Y1. So basically, this should be 1 divided by W1 plus W2. So this is to be your equation if you would be solving for the location of your center of gravity in this plane right here. So going back to centroid, so once again, your centroid is to be the geometric center of your given body. So in these shapes right here, so for your triangles, for you to get the geometric center of it, just draw a line from one of your vertex to, by the way, so one of your vertex to the median of one side. So it would be the center of one side. And after that, draw another draw another line from the vertex to the center of one line, and draw another line from the vertex to the center of one side. And the intersection of all of them would be the location of your centroid. So this is to be for the centroid of your triangle. And as for the centroids for your rectangles and your squares or your parallelograms, you would be drawing diagonals from its vertex, from vertex to vertex, and their intersection is to be your centroid. So this is to be your centroid. So same is true as with this square right here. So the intersection of both diagonals is to be your centroid. So that is for these parallelograms right here. And if you would be visiting mathalino.com, the centroids of these basic geometric shapes are already specified. So for the centroids of rectangles, so for you to get this location of the centroid right here, that is basically, so for bar X, that is basically half of the base. And for bar Y, that is basically half of the depth. So it is in this center right here. But for triangles, so the centroid of your triangle is basically 1/3 from the bottom and 2/3 from the top, because as you can see here, bar Y is equal to 1/3 H. So if this is to be 1/3 H, the remaining here would be 2/3 H. So that is for triangles. And as for the circles, so if you would be getting your reference point about this point right here, X is equal to 0 and Y is equal to 0. So meaning the center of your circle is, well, basically in the center. And this is this is to be the formulas for the areas of all of these basic shapes. And as for the semicircle, since that is to be a semicircle, your area is to be half the area of a circle, and your bar Y right here. So this would be a new formula for you to memorize. So for the centroid of a semicircle, your bar Y, which is this one right here, is equal to 4/3 R divided by pi. So it is better for you to memorize that. So for this is to be an arc. So take note, guys, it is an arc and not a semicircular area. So it is not an area. So it would just be a line. So for your quarter circle, bar X is equal to 4R divided by 3 pi, and bar Y is also equal to 4R divided by 3 pi. So basically, both of your X bar and Y bar is the same. So better get familiar with these formulas right here, and you can check the website by Sir Junvert, which is mathalino.com. And these are also some of the basic shapes that you can memorize. So this is for ellipse, half ellipse, spandrel, parabolic segment, sector of a circle, and whatnot.